Hello. So this section has a lot of vocabulary as well. So all this purple vocabulary stuff, that's all from last section. I just wanted you to take a moment so you can pause the video, take a moment and see if you remember what those things mean or go back and look what they mean. All these things in blue are going to be the new things that we see in this section. So the first thing we're going to talk about, the blank of a triangle, is a segment whose endpoints are the vertex and the midpoint of the other side. So from the vertex to the midpoint of the other side, that is called the median. So the median always goes from one of the vertices of the triangle. So we'll use this one in this example. And then it just connects to the midpoint of its opposite side. So as you can see, this is the midpoint because this segment and this segment is congruent. So this point has to be right in the middle. So that's a median. So the centroid, so that's another vocabulary word. The centroid of a triangle is all of the medians connected to each other. So if you look right here, let's see, what color do I want to use? This is a midpoint between G and A. And it goes from vertex L, so that's a median. This is vertex G, and then this is a midpoint between A and L, so that is another median. And then vertex A goes to this midpoint between G and L, so that's our third median. So where all those connect, that point right there, the centroid. So one thing that we need to know about the centroid is that the length from a vertex to the centroid is 2/3 of the length from the vertex all the way to the midpoint. So the length from L to the centroid would be 2/3 of the length from L to the midpoint. So we'll do an example of that in example 1. So example 1 says NY, SA, and CU are medians of the triangle. So that means they all connect here, so that's the centroid. Find the length of the following segments. So they tell us that SA is 9. So all the way from S down to A, that's 9. So from here to here, it's 9. So what I was just saying with that 2/3 thing is that the distance from vertex S to the centroid is 2/3 of the length of S to A. So to figure out what SO means, I would have to multiply 9 times 2/3. So if you have trouble multiplying fractions times whole numbers, just make 9 a fraction, so 9 over 1, and then you just multiply across. So 9 times 2 is 18, 1 times 3 is 3, so that'd be 6. OU is 4, so then I gotta find OC. So OU is 4, so what's gonna be the length of the entire thing? So if this is 4, I need to figure out a length right here. To find out CO, if I knew the whole thing, I'd multiply times 2/3. But I don't know that. So I need to figure out what number whoops, I probably shouldn't tell you the answer right away. So if this is 2/3 of the length between C and O, then that means OU has to be 1/3 of the length. So if I know 1/3 of the length is 4, but I want to know 2/3 of the length, to get from 1/3 to 2/3, I multiply times 2. So if I know 1/3 of the length, I can just multiply that times 2, so 4 times 2 would be 8. And then to find CU, let's use. So the entire length from C to U, if this is 8 and that's 4, that would be 12. And then finally, ON is 4. There's ON, that's 4. So this time I know the longer length out of these two. So this is the 2/3 part. So that's 2/3. This would be the 1/3 part. So if I knew the smaller length, I multiplied times 2. So now if I know the longer length, I divide by 2. So 4 divided by 2 will be 2. So in example 2, in triangle MAH, MT is a median. What is the length of MT? So if MT is a median, that means it goes from the vertex down to the midpoint. So if T is a midpoint, what do we know about this length and this length? Well, those have to be congruent. If those two are congruent, then I know that 3x plus 7 has to be equal to 28. So I could just solve for x. So subtract 7, I get 3x equals 21. Divide by 3. So x is equal to 7. So now that I know x equals 7, and that's going to be true for all of these equations, if I'm trying to find MT, and MT equals 7x minus 10, I can just substitute 7 into x. So 7 times 7 is 49. 49 minus 10 is 39. So MT equals 39. Now on to the next page. So the blank of a triangle is the perpendicular segment from the vertex to the blah, blah, blah. So this is an altitude. So another word for altitude is height. So altitude would be this length, could be this length, this length. So it's basically just asking for the height or telling you to find the height. So in example 3, is AC a median, altitude, or neither? So if I look at AC right here, notice that that's perpendicular to BC. So that's going to be an altitude. It's definitely not a median because for it to be a median, it has to go from the vertex to the midpoint over here. So it definitely doesn't do that. It is an altitude, so obviously it's not neither. So in example 4, LY is an altitude of triangle LBD. If the measure of angle LBY is 49 degrees, find the measure of YLB. So LBY, L to B to Y, so this would be 49 degrees. LY is an altitude, so that means these are 90-degree angles. So then we got to find the measure of YLB. So YLB would be this angle right here. So we do have, let me use the yellow here. We do have a little triangle right here. Notice that we have two of the angles. So this is 90. This one's 49. So now we just need to figure out the third angle. So remember that all triangles add up to how many degrees? Hopefully you said 180. Let me erase this M that I don't need anymore. So 90 plus 49 plus x has to equal 180. So 90 plus 49 is 139 plus x equals 180. So x has to equal, if I subtract 139 on both sides, I get x equals 41. So that angle would have to be 41 degrees. So the measure of YLB is 41 degrees. And then finally, example 5. What are the coordinates of the orthocenter of triangle LMN? So if you remember from earlier on this page, the orthocenter, if I go back, oops, actually I don't think I mentioned that. Orthocenter is where all the altitudes of the triangle meet, or the point of concurrency of all the altitudes. So I forgot to mention that. So that means on this triangle, I just need to find where two of the altitudes meet. And that will tell me where the orthocenter is. So this is one altitude. That's the height of the triangle if I look at it vertically. If I kind of look at it sideways, I'd have to find a point on here that is perpendicular with this line. So let's say right here, I don't know. And then about right there. So I really only need 2, but I'm just using 3. So this would be the orthocenter. So that point, it's kind of hard to see now, but it looks like it's at 1, 2. So that's the orthocenter.